All right, so now we will take a look at this question and we'll solve this using our three equations, one of those three equations essentially. So let's see how we can solve this. A particle has an initial velocity of 3I plus 4j because its velocity, it's a vector, and acceleration of 0.4I and 3j. Its speed after 10 seconds is okay. Right. So what is given to us? Let's see the initial velocity. So we can write u as 3, which is essentially vector u 4j meter per second. Let's consider this the standard units, and then v is we don't know, and the acceleration is 0.4i plus 0.3j, again meter per second, although the unit hasn't been specified. So we are considering the standard unit, although one can consider just as unit per second. How we can solve? So what do we know? The initial velocity, final velocity, a, and also the time is given 10 seconds. So we'll refer to the equations. Do we have any equation which can straight away be applied? Yes. That is equation number one, which is this. We will apply this and solve the problem. What is the equation? V is equal to u plus at. We will use this equation. Okay, we need to calculate V. What is u? 3I plus 4j plus 0.4I plus 0.3j. This needs to be multiplied with time, which is 10 seconds. And this becomes 7I plus 7j. Yeah, meter per second. So this is velocity. Velocity is 7I plus 7j. Okay, let me get rid of this. So we got the final velocity. All right, so we have the final velocity as this. And in order to calculate the magnitude, what should we do? So understand, students, let's see. So this is x-axis, this is y-axis, and I vector is along x-axis and j vector is along this. So how do we get the magnitude? Magnitude we can get for this 7 square plus 7 square under root. This is the magnitude, which is, we can write it as meter per second. Looking at the options, so option C is true, right? So how do we get? Okay, good. So we have solved this problem. So what are the important learnings from this? The important learning is essentially use the generalized equations, meaning the vector form of this equation is very helpful. It will help you to solve any problems. Okay. All right. Now we will consider a scenario and solve the problem related to free fall of the body. So uh, consider a place above the earth and a ball is thrown down from this point and it falls and hits the ground. This is ground level. Okay. So ball will fall and fall in straight line. All right. So we need to calculate couple of things. What would be the velocity at a particular point? For example, P. What would be the velocity at point P? What would be the velocity at, let's consider this point as F, right? So we'll calculate all this, and also we will understand if it took a particular time, what was the height. So these kind of questions we'll try to solve. So for that, to start with, let's consider this as an origin point. This is the origin in our coordinate system. We have assumed it, and no harm in that, because you can assume any coordinate system, and everything is relative to that. So we're using the general principles here. So let's assume the position of this point P in vertical direction as y, and this is origin. So we'll calculate the velocity at point y. Okay, so we will solve this problem by using the general equation. V is equal to u plus 8. Okay, so we want to calculate the velocity at point y. What is u? The initial velocity is 0, because we dropped the ball from point O. It's 0. What is acceleration? Let's understand this. What is acceleration? So acceleration, due to Earth's gravity, is g. The magnitude is g, right? What's the direction of this acceleration? Direction is downwards. It tends to accelerate the particle downward towards the Earth, and the unit is meter per second square. So it's g meter per second square. If we consider this coordinate system where the downward is negative, so the acceleration is minus g in j direction. So we are considering this as j times t. J is what? The unit vector along y-axis. So velocity at point y would be Vy would be negative, right? So if we just consider uh, the magnitude, or the magnitude is Vy, it would be minus J. Is this right? So where Vy is the magnitude, or you can just write it like this. So we'll place this minus, and here we are applying this modulus minus G GT. So Vy, we are just considering the magnitude. So GT is the Vy, right? So at any point, the velocity is dependent upon time, the time it takes to reach the particular point, right? What else can we calculate? Let's calculate the height it will travel in time t. So velocity will continuously increasing, so we cannot directly multiply this with time. So we need to use the equation, which is equation number 2. So this equation will be using. What does this equation says? The position r is ut plus half gt square. So here, let me generalize it. Sorry. Let me write the general expression. Half 80 square, position vector r. So position vector r, I'll generalize this as well. We know that the particle is falling in the straight line, and the x-axis is always 0. So at the particular point P, the position would be y minus yj. The initial velocity is 0, half minus g times j t square, which gives us half gt square. This is the position y of the particle at time t. Okay, so we have calculated the velocity at point y as well as the position or the y axis value at time t. All right. So if we have to calculate the time it takes to uh, reach the final position, right? So how do we calculate that? The time it takes to reach the ground. So we can get this from this expression 2y divided by g, it's t square. Y, let's assume y equal to h. What is h? H is the height, means the height from which the particle was dropped. So we are considering y equal to h at this position. Uh, Sorry, let me erase this. Right. So we have seen the height is h. So when the particle lands the ground, it covers the total distance h in the vertical direction. That is the height from which the ball was dropped. So let's put this here 2h by g. So the time is essentially 2h by g under root seconds. So for this amount of time, particle remains uh, in motion, and the time it took to reach the ground. So remember, it's dependent upon the height or square root of height for calculation of the time. All right, so with this, we have solved the problem of free falling body from a position up in the air, and we have calculated the final velocity, the position y of the particle, and the time it takes to reach the ground. So consider a scenario where you are throwing the ball and obliquely, meaning it's not straight up, but it is making some angle. And we will generalize this even for the vertical up throw. But for now, let's assume the ball is getting thrown, or an object or particle is getting thrown at an angle up in the air. It will go up and eventually it will come down, right? We have observed that with ball, I mean stone, anything, right? So we will get to study that motion, and using our three equations, we will solve the trajectory, the path it will take, and also we will determine its velocity at a specific point during its motion. So let's draw this scenario. So let's assume this is the ground level and the object or the ball is thrown. It will go like this, making some curve path, and eventually it will land at a particular point. Let's assume this point to be P. And let's assume the ball was thrown from point O. So this whole OP length is known as range. And this motion, we call it as projectile motion. Uh, this point is known as point of projectile, and this the time it takes to reach to point P from O. So we call it as time of flight because it remains in air. And then what else is important? Yeah. So there is an angle this projectile makes with the ground. So we call this angle as angle of projectile. So I'm drawing the vertical axis. Let's call it as y-axis and x-axis. Okay. Essentially, the motion is getting studied in 2 dimension here, and we would be using the general equation, the equations which we have learned earlier. So yeah, so we will calculate a couple of things. First, at a particular point q in this whole trajectory, what is the velocity? So let's assume the horizontal velocity is vx and the vertical velocity is vy. Okay, so we will calculate vx and vy. The initial velocity was say u vector, but its horizontal component is ux and vertical component is vy. Right. So let's write the first equation of motion, that is v equal to u plus at. What is v? So v can be written as vxi plus vyj. What is I and j? I and j are the unit vectors towards x and y respectively. So we have replaced v as vxi plus vyj, u as uxi plus uyj plus at. What is a? A is equal to minus g. Why? Because the direction is downwards. The g is downwards. So we can replace this as minus g. Why? Because I am also putting the vector j, which is upwards. So it's in the opposite direction. So hence I put this t. Right. So we got from this equation vx is equal to ux. Why? Because I have compared the I or the x-axis component to the x-axis component. So initial velocity is means the velocity in the horizontal direction at any point remains the same as the initial velocity. Then Vy is equal to Uy minus Gt. So we got this by comparing the J or the vertical components, right? So this is one, this is two. Okay, so what is Ux? Ux can be written as U cos theta. How? Because if we calculate this ux, which is equal to the horizontal component of u, and that can be derived by putting like this, right? In the same way, ui is u sine theta. So we can always get vx using the equation. So we get the vx as u cos theta and vy as u sine theta minus gt. Right. So what else can we calculate? What do we need to get? Let's try to get the time of flight. Time of flight. How much time did it take to reach to the final position where it falls down to the ground? So what are the things which we know when it reaches the ground? we know that y would be 0 when particle falls, and essentially, what do we know? We know y would be equal to 0 when particle lands the ground, right? So, meaning if we calculate this y, we can solve the time. So, using the equation, another equation which we had derived earlier, the law means for motion. So, again, we'll replace this xi plus yj, meaning let's assume the position vector are x and y at this position. So we can write this as xi equal to yj, xi plus yj, and u cos theta plus u sin theta multiply by t minus half g t square. So we'll compare y becomes, we're just comparing the j component, u sin theta times t minus, this is what I and this is j, right? Minus half gt square. So we are comparing these only the j components. So comparing j component, right? So what we are saying, when it lands the ground, y is equal to 0. So hence we have u sine theta, this multiplied by t, half gt square. So essentially we get this t as 2u sine theta divided by g, and we call this as time of flight represented by capital T, 2u sine theta by g. Very important. Okay. So we got the time of flight. We would like to know the range as well, right? How do we get the range? Can get it easily by using this equation, wherein we compare the j component. Let's compare the x. Let's compare the I components. Compare the I component from this equation. So, excuse me, xi equal to u cos theta multiplied by t. So we'll place this t, and this is the horizontal range. So let's consider this as, say, OP. Horizontal range OP is equal to 2u sine theta by g multiplied by u cos theta, which becomes u square 2 sine theta cos theta by g. It becomes u square sine 2 theta divided by g, which is the projectile range. All right, so what we have calculated till now, so we have calculated the projectile range, which is this length, the whole length, and then we calculated the t, which is the time of flight to reach from O to P. Now we will calculate the maximum height of the projectile. So at the maximum height, what will happen? At, at this position, the vertical velocity will become zero. And we will use this observation or aspect to calculate the height. So using the equation earlier, which equation shall we use? Y is equal to u sine theta t minus half gt square. Right, and for that, so we can use this equation, and for that we need the time t. So meaning we need the time at which the projectile reaches the vertical velocity equal to zero, and for that we can use this equation vy is equals to u sine theta. Okay, so vy is equal to u sine theta minus gt. So we get the time t as it's zero, right? Vy is equal to zero at highest point of projectile motion. U sine theta divided by g, because Vy is equal to 0. We have placed this. So we got the time. And now we will be placing this time in this equation, which calculates the y. Okay. So y is equal to u sine theta. So u sine theta by g, I'm placing this in the previous equation, minus, what's the minus? Half gt square. Half g u sine theta by g square. Right? If we simplify this and considering y as capital H, which is the maximum height, so we will get how much? U square sine square by g, u square 2g. So it will be u square sine square divided by 2g. This is the maximum height. Okay. So this is the maximum height reached by the projectile. So we can see what we have calculated: the maximum height of the projectile. We have calculated the range of the projectile. We have calculated the time it takes to uh, cover the whole motion, the projectile motion. So, and all are dependent upon this value theta. For example, in this projectile motion, if we imagine the body is thrown vertically up, in that case, the theta would be how much? 90 degrees. Theta would be 90 degrees. When it is 90-degree, what would be the range? 2 theta becomes 180-degree. 180 sine would be 0. So there won't be any range because the particle is going up in the air, right? So OP is equal to 0. And then the time it takes to complete the motion, right? So time of flight would be sine 90. That would be 2u by g, which is right. It takes 2u by g to complete the motion. And then, and we can calculate that as well, right? So if the particle is thrown from this position O, it goes up in the air, it will come down as well. So we can calculate this motion. We had calculated one aspect of throwing the particle vertically down, but we can calculate this as well. And for that, you can use the same concepts, right? Uh, what would be OP? We have seen it's going to be 0, and then the maximum height. The maximum height would be how much? It depends upon the initial velocity multiplied by 2g. So this would be the maximum height reached by the particle. So with this, we have finished talking about and understanding the projectile motion. And in our next session, we are going to solve more problems to understand all the concepts deeply. Thank you.